let's take a look at a Philips lighting Xtreme surge protector as used in street lighting and other applications. And this is basically wired in parallel with your supply. It's got a couple of holes for mounting it into a gear tray, or you can actually screw it onto just a hole in the metalwork. And it's got push fit connectors, and if you look very carefully, and it's not very bright, see the wee green flickering dot? That is the indicator that everything is good. It looks like an LED, but it's very, very dim. Right, tell you what, let's unplug it, get the wires out. Hopefully it doesn't hold a huge charge. So I shall push down on these connections, because they are just push-in connectors. And we'll open it up, and I shall take it apart, which is more or less the same as opening it up. Let's zoom down onto this so we can see it together. Hopefully this is going to come apart easily. That's not bad. Is it going to be potted? No, it's kind of potted, if these are what I think they are. Does this come off? It does. There's the LED. There's a gas discharge tube going to the earth. Here are, these look like, I wonder if these are from TDK as well. These are very similar to the ones. I kind of want to take one of them off. Right, I probably will. Okay, let's take a picture of this and then I'll reverse engineer and we can see what's inside. One moment, please. Bit of desoldering and reverse engineering done. And resume. I thought these were potted and they're not. So that means we can do a little experiment with one. We can trip the thermal fuse in this. So what I'm going to do is I'm going to put a little bit of solder, fresh solder, onto the solder iron so it couples on well. I'm going to bring it up here. I'm going to zoom down and then I'm going to focus on that so it's nice and sharp. And then we'll heat this up because this is a spring attached to a metal oxide varistor on the other side. And when it gets hot, it just pops open like that. How simple is that? That is really quite neat. Also, technically speaking, you could put a new metal oxide varistor and reset it, but that's not recommended. It also means that technically speaking, you can reset this one. However, that's also quite nice because look at the heat path here of the spring, which means that when you solder it in, it's less likely to stress the device. Very nice. And the metal oxide varistor itself is just going in a bit of a, well, I can pull this out now more or less, can't I? Can I pull this out? It's got that connection there, which is going down a little metal pin. Oh, that metal pin is going down, the solder's stopping it coming out. But this other one is going down a bit of sleeving, or is that a bit of sleeving? No, it's all moulded in tubes in this. Right, tell you what, let's get down onto the schematic. One moment, please. So looking at the circuit board, it's quite odd because I wonder if this circuit board is designed to have multiple functions because there's positions for capacitors. It's strange that they've shown them as round. Here and here and here and here, plus all these links marked F1, 2 and 3. There is this gas discharge tube. It's EPCOS, which is part of the TDK thing again. I think these are also TDK components, which TDK, as soon as I see TDK, I think of old magnetic cassette tapes. But they're a big player in the surge suppression because MeanWell and Philips, that's two of the biggest players using their components. The other thing you can find on here is a resistor which is part of the circuitry limiting the current to this LED, but it's not the main component limiting the current to the LED. 220k, red, yellow. Actually, let me check something. Nope, that's fine, it's 220k. Red, yellow, which is 2, 2 and 4, which is 4 zeros, so that's 220,000 ohms. But then they've got the gold, and then they got a black. I wonder, that's going to be one of those weird resistors with maybe just an indication that it's also a fuse or something. Not really sure about that. That's quite strange. But then it's going to the LED, but via other circuitry. Let's take a look at the other side. And this is where it gets more interesting. We have the incoming supply on these push-down connectors, loads of support here. We've got these mysterious pads that look as though they could actually be a more basic filter, just with basically a capacitor between live neutral and earth, and maybe there's a version that does that. But they're going to these metal oxide varistors with the built-in fuses as shown earlier. And the middle pin is this feed pin to that fuse, and then it cuts over to the actual metal oxide. The varistors, the two outer pins. And you've got one across live and neutral, and you've got two going from live to earth and neutral to earth, but then they don't go straight to earth. There is that gas discharge tube rated about 600 volts, I think, going to the earth to provide separation so there's not current flowing to earth. The circuitry for the LED is a tiny little capacitive dropper, and by tiny I mean that capacitor is an extraordinarily low value, like 3 nanofarad. And then a very simple, the simplest possible way to make the LED light. I'll show you it in the schematic. So here is what we have. Right. I'm just going to pause a moment, just double check something. Something is casting doubt into my mind at the moment. Nope, it turns out there was no reason to be doubtful at all, as often happens. So these devices are T20, K320, 320 volt RMS rated, and they're designed that at the point, normally you determine the voltage, I'll zoom down a little bit, of these metal oxide varistors is the point at which they're passing 1 milliamp. That's just a threshold voltage they're starting to turn on. In this case, it's apparently 510 volt. It's interesting to note that components inside, the actual disc itself is called T20, K320. So we have the neutral coming on via this thermal fuse, and the way it goes through the thermal fuse, the neutral goes through this thermal fuse, and then it goes through this thermal fuse, and then it goes to the monitoring circuitry, while the live goes through this thermal fuse and goes to the monitoring circuitry. So any of those fuses breaking will actually trigger the LED to go out. So the metal oxide resistor across live and neutral is just connected after that fuse. If it starts overheating, the neutral will break, and that will break the circuit through that. The ones to earth go from the neutral via that fuse, and that fuse to the earth via this gas discharge tube. The live likewise goes through that fuse to the gas and the metal oxide resistor to the gas discharge tube. The circuitry here is basically a capacitive dropper, but the most absolutely minimalist type. It has a tiny capacitor, that's why it's just barely aglow, but it's probably a gallium nitride LED, so microamps are fine. It has that 220k resistor, the 3 nanofarad capacitor, it's got the LED, then a reverse diode across that, because otherwise the capacitor can't discharge and charge, and that's how it works, basically, the capacitive dropper. And then it's got a 27k resistor across it just to shunt any leakage, which I wouldn't expect. I'm not sure if that's even needed, but they've put it in for a reason. So there we have it. Ultimately, it's basically just a metal oxide resistor across live and earth, neutral and earth, with an extra barrier, the gas discharge tube. And if any of the thermal fuses go, the LED goes out. Not that any of your average street lighting engineers, because this is where these are really intended for use in street lights and other applications like that, not that they're ever going to ever look at the LED to see if it's lit or not. They just wouldn't do that. Because that's the nature of it. But if I was being cynical, I'd say that this is primarily a device designed to get these units out of warranty. And it's worth mentioning that on the Isle of Man, they recently refitted a lot of the lighting in Douglas, the main sort of capital city of the Isle of Man, with state-of-the-art architectural LED lighting fixtures with RGB colour changing. And they got struck by lightning and it took the absolute whole lot out. So maybe they would have benefited from these devices that would have actually perhaps prevented that. If it was the power supplies that blew up, but not if it was the actual, like the control network that blew up instead. But interesting stuff. It's quite well made. It's designed for use in streetlights, so I'd expect to be quite rugged. An interesting little surge suppressor.